Hey, I'm James with Esprit Tech, and welcome to our very first live stream, episode 1, all about the Jeti Assist receivers. Don't forget, everybody who's watching, it is Valentine's Day tomorrow, so make sure if you want to stay in good graces of your significant other, you go out and make sure you've got something that you can leave for them tomorrow. We're just happy to have you guys with us today. This is our first one, so if you see any technical difficulties that are throwing you off or anything's not working, make sure you hit us up on the comments and let us know. We're going to try and get to all the comments. I can see what you're posting. I've got somebody in the background also helping us answer those if she's able to. So go ahead and post things up if you have direct questions as we're going through the assist. We'll try and stop once in a while and cover those. I'm not going to guarantee we'll get to everything, but we will do our best. What is Jeti Assist? Jeti Assist is a stabilized receiver system. It's a 3-axis stabilization using accelerometers and a MEMS ring setup or gyro setup. It does improve the way most of your aircraft are going to fly. I get a lot of questions here at the shop about where you're going to use that. You know, I get calls about, hey, I'm building a big P-47. Should I use a Jeti Assist receiver? In most cases, the answer is going to be yes. If the plane is already going to fly good, it's just going to make it fly better. If it has a few bad tendencies, it may help cure those. Aircraft that are particularly difficult to land, it'll help a lot with those landings. A few places where you probably aren't going to want to use it. The system was designed to be a standalone receiver with a backup receiver. It's not designed to input to a power distribution device like the 200. That wasn't the original intent. We will follow with a standalone for that purpose, but for now keep in mind that if you're going to do a bigger system where you're using a central box 100, 200, or 400, you may want to go with an external gyro system from a third-party provider. For anything smaller, absolutely. Throw an assist receiver in there, back it up with a 900 or another 2.4, and you'll be good to go. Don't forget that you can use this in a multi-rotor capacity as well. We have tested it here. We threw it in a little 550 size multi-rotor, and it is very easy to set up. It gives you all of the PIDs so that you can set it up very precisely for what you want. It's a little different. A lot of the stuff on the market doesn't give you both, and this one does. So just keep that in mind if you do decide you want to tackle a little multi-rotor project. This will run 4 to 8 rotors, so it is very expandable as far as that goes. In the airplane side, you can use this, like I say, in just about everything, from your aerobatic basic airplane, your pattern type airplane. One of the places I wouldn't use it, obviously, during flight anyway, is big sailplanes or small sailplanes. Keep in mind that in a sailplane, you want the aircraft to indicate lift. You want to see what's happening in the air. And with a gyro stabilizing the airplane and those movements that are caused by thermal air or lift conditions, you're not going to see that with a gyro. So one of the things you can do in a large sailplane is you can run the stabilization and just use it during the tow up and the landings. So let me look down here at the comments. Nice, nobody's got any questions yet, so we want to get into a little bit of the programming. Now, I've gone ahead and set up the radio with a basic model. We've bound it to our display. A lot of you guys who've seen us at the shows have seen this model. It has the assist set up on it. We did start with a whole new model program just so that you guys see everything right from the very beginning. So the only thing I've done so far is I set up a 2-aileron, regular tail, normal airplane. We're going to go ahead and add the functions that you're going to need, and we're going to jump into the assist programming. So if we can go ahead and switch to camera 2, we'll go ahead and do a little programming. We're going to go ahead and jump into the menu. The first thing that you want to do is get the model set up correctly in the transmitter. So we're going to go into function assignments and take a look what we've got set up. Actually, let me back up because this is a question I get a lot. In basic properties, when you're first setting up the airplane, one of the things that you do not want to do is activate the gyro in the basic properties. You want to make sure that that says no. You're not going to use the gyro sense function or the gyro settings menu that exist in the standard programming. So with that saying no, we're going to go ahead and move on into our function assignment. We're going to do a basic setup to start with. So one of the things you're going to want to do, or going to need to do, or have to do, is we're going to go ahead and add a function. We're going to call that mode. This is what is going to allow you to switch between your 3 gyro modes. Typically those are your off, normal, and hold. So once you have that, you're going to want to assign that to a 3-position switch. I'm going to use my SA switch, and I'm going to click OK. Moving forward, we'll click OK for that. We're going to go ahead and jump into our servo assignment tab. Make sure that we assign that mode switch that we've just created, and we're good. One of the things that you're going to want to do is check the airplane, make sure that all of your normal flight controls are working, which we've done. So I'm going to go ahead and power up the airplane off camera here. You guys know how that works. You don't need to see it. And we want to jump into our Device Explorer so that we can get into our setup and programming. So I'm going to log into the Rec 7A, which is what we're using on this example. Very simple menu. Configuration is where you will set it up, go through the wizard, have all of the tabs pertaining to the gyro. Telemetry, of course, is your live feed from the aircraft, and as you can see, it does give you all of the position indicator data, and if you move the airplane, that is live. If we go back, telemetry min-max gives you the largest recorded values from each of those parameters. And then the vibration analysis is yet another thing that you can use to diagnose and set up the model. So we're going to go into configuration and go into our quick wizard. Quick wizard is going to be your first step. It's going to be the most important part of your programming. So you definitely want to, the first time you go through especially, you're going to want to go all the way through the wizard and make sure you complete it. In its default state, it'll ship in assist off, which means if you don't want to use the assist portion of the receiver, but you've got one laying around, you want to throw it in an airplane, you can leave assist off full time and run the airplane run the receiver as a standard receiver. So we're going to go ahead and choose airplane for our example, and we're going to apply the change. And while I am going through that, let me take a look. All right, so Russell had a question on the live stream here that I should probably jump on real quick. When you're using the assist receiver, when I say standalone receiver, I only mean that in the fact that you're not using that with a power distribution device. You would be using that with a secondary receiver if you wanted the redundancy. That can be another 2.4 receiver, or that could be the 900 megahertz receiver if you're flying on the 24 or the 12. And in a large warbird like you have here at SISP-47, full controls, yes, so long as you are able to make that work within the 12 receiver or 12 channel limit that you have, or 12 pin limit that you have on the Rex 12 Assist, that would be a perfect setup. Actually, my setup would be a DSM-10 for battery management, either the magnetic switch or the R3 wireless switch to turn it on and off, a Rex 12 Assist to handle your servo output duties and your stabilization, and I would back that up with the 900 megahertz receiver. In an airplane like that where you don't have multiple servos on a single hinged surface, you really don't run into the need for a power management system with the fused outputs. So you really run into that when you're building larger aircraft where you have competing issues or a big mechanical retract. something that can bind and draw a huge amount of power is where you want the fused output. So for the example we're using, definitely it would be perfectly acceptable to run it, the assist, a backup receiver, and some type of battery switch. So will it ever be able to be used in a helicopter? That's a really good question, and it's something we've posed to the guys at Jeti. All of the necessary electronics are there. The problem is Jeti is not a helicopter company, by and large, and they don't have someone there to work on the collective, or the mixing, the CCPM mixing. So I don't foresee it becoming a helicopter device. The helicopter market is shrinking, and even more so in Europe. So for now, we're definitely focused on the fixed wing side of things. Who knows, it may change. I'd love to see that. I just don't count on seeing that happen. Let's take a look and see vibration analysis. Yeah, we can back up to that. Let me jump out of my wizard. And don't worry, if you do this, you can jump right back into the wizard and go back through it again. So in the vibration analysis, yeah, thank you, Jason, for going back to the radio. You're going to select the axis that you want to look at, and it is based on each specific X, Y, and Z axis, and it'll give you the vibration in hertz. And I don't know, because I don't have a motor running on this, I don't think that I can give it a whole lot. Yeah, I can move it a little bit, but we're not going to get a whole lot out of it. This is more higher frequency vibration. The reason for that is that that's what throws the gyros off. Small amplitude vibration, like what you're able to demonstrate here in an airplane, is never going to show up on the meter. It's going to be the buzz from your fuel motor, your electric motor. So far, we haven't had issues in turbine, EDF, electric prop drive, or gas prop drive airplanes. So we've done really well with it. But that's what the vibration analysis is for. If you are getting some weird stuff, some weird drift, some weird action in the aircraft, while it's running in stationary, you can go to the analysis tool and look and see where that vibration is and work to isolate that vibration. The less you see on the monitor while the aircraft is running, obviously the better you are. The more stable that receiver is, the less high frequency vibes it's seeing, the more comfortable it's going to be, and the better the programming is going to be, the better it's going to fly. So hope that covers that one for you. We're going to go ahead and jump back into our programming here under our wizard. So we set this up for airplane assist. After each setting, you're going to go ahead and scroll down and click next. In this airplane, this is perfect. This is a small acrobatic airplane, so that's what we're going to choose. I'll click on that to give you an idea. There are quite a few different types of models included in this. For you high-speed guys, you know, the glider dynamic setting is great if you're out there flying an X Plus at 200 miles an hour. If you're flying the slow-speed gliders and you just want stabilized flight for your approaches, you can choose the glider slow. Trainer would be your typical high-wing setup. Foamy is a little more active. The reason these are in here is each of these has pre-configured gain values and adjustments in the algorithms to apply to this type of model. You don't want particularly kind of one baseline. It keeps you from having to set everything individually if you choose the correct model. So we're going to go with Acro Small, and we're going to scroll down and choose Next. The next page that we get to is probably the most important one, and this is your orientation in the model. This is going to be critical. You get this wrong and the model will only fly once, and that's a promise. So you want to make sure that you take a look at the receiver itself. Jason, can you go to camera 1 for me for a second? Okay, so if you have on your receiver, if you take a look at the assist, at the very top corner of the receiver, you'll see where it actually says assist on it. There's an arrow there that indicates the direction of travel. So that's what this picture on the transmitter references. So if you can go ahead and go back to camera 2. So you'll take a look on the screen. You can see where you have a small picture of the assist receiver with the arrow, and that matches the direction of flight. So if you click on the list of different orientations and scroll down, that image is going to change. So rotated 90 degrees is going to be the assist arrow pointing towards the left wingtip. So you always want to make sure as you choose this, that image matches what you have in the aircraft. That's going to be really critical. So the one that we're using is a default horizontal setup where the assist arrow points to the nose of the aircraft or the direction of flight. Once you have that set, of course, go on to next. Couple of the assist properties here. The use gimbal only applies if you're working on the multi-rotor or a big fixed wing platform with a gimbal system that you're stabilizing with the assist. Most guys won't ever click that. And then all servos digital, that's going to be up to you what you have in the aircraft. We are set up that way, so we're going to go ahead and click all servos digital, and we're going to move on. Probably the second most important step in the entire setup. This is calibrating the channels. What this does is neutralizes any trim settings that you've made when you set up the plane initially. I do always recommend, and this is kind of important, a lot of guys don't do it this way. I do. It's worked better. Set up the airplane with the assist off. Trim the airplane, get everything set up. Go and make the trim flights that you need to make. Make sure the airplane is functioning the way you want it, and then do your assist setup. You can do it in the other order, and you can do it in the field in this order as well. It just seems to work better if you make sure the airplane is right first, and then you go ahead and build the assist into that after the fact. So the way you do the calibration is you click on Calibrate Ailerons. It instructs you to center the sticks and press Next. So we're going to go ahead and press Next. And it tells you on the screen what it wants you to do. Move ailerons fully to the right, repeat to the left and back, and it has calibrated that channel. You'll scroll to the next, which is elevator, and don't mind the noise, sorry about that. Now, center and press, sorry, I skipped a step. So the sticks are centered. We'll press Next, and we will pull for fully up. We will push for down, and it is calibrated our elevator. We're going to go ahead and click on our yaw, center the stick, and this is centering the stick only in the axis that we're working. So I'll click Next. I will move fully to the right, fully to the left, and now we're calibrated. And as we move the stick, you can see that if I don't do any mixing, that we're getting our roll input, and that's what you want to look for. Make sure you're not getting any mixed inputs in there. So once you've calibrated, you can scroll to Next, click OK. Here is where you're going to assign the flight mode channel. This is why we set up the mode in our function assignment and assigned it to a switch. You're going to go down, click on flight mode channel, click on edit, so it'll clear any pre-assignment, and we're going to move our switch. So now you'll see that it changes 3, 2, and 1. So it is picking up our 3-position switch and our mode command that we've assigned. So I'm going to scroll down. I'm going to click on, actually hit escape once to unhighlight the channel. Go to Next. Once you're done, we've done the calibration. We know everything that we've done so far is correct. We can go ahead and scroll down and click on Apply Wizard and Finish. So we're going to click on that and click Yes to apply. Once that finishes loading, now we've set up the assist. We've turned the assist on. We can go through and actually build our assist program into the airplane. So the first thing in the list is our airplane settings. This is our basic gain value. You have a sub value or a basic gain value of 50%, a sub value which is listed here. It's a multiplier of the two. You have two separate ones. The column on the left side is your regular gain. The column on the right is heading factor. So if you're flying in normal stabilized mode, your gain value is what affects that. If you're flying in heading hold and you want a little more hold, it's rolling off the command or it's not quite holding that position, you can increase the value there. If you scroll down, next thing you'll see is 3D aerobatics factor. This is a unique one to our system, I believe. I don't recall seeing this anywhere else, and it did catch us out in the beginning. It gives you stick priority, and it's defaulted to 60%. So depending on the type of your airplane that you're flying, that value is very low. That basically means that you have 60% priority over the command, over the control. The system has 40%. So it's going to retain 40% of your movement and only give you that back in recovery command or system control command. So if you're flying an aerobatic airplane, 3D airplane, something a little more fun, you want to go ahead and try and click on those roll stick priority numbers and raise those up. For 3D, I fly 100% stick priority. That means at the limit, I'm not getting any corrective action. So if I'm at full stick, I don't really want the system fighting that. Anybody who's flown any of the early gyro systems and flown aerobatics knows that at full stick input, it felt like the airplane was fighting you. Running 100% stick priority defeats that feeling or takes that feeling out of the airplane. Gives you a very crisp feeling. If you try and fly aerobatics at 60% priority, it feels very mushy. It feels like you're flying on a very low rate, and it's not very fun. So you're going to want to adjust that to your preference. I run 100%, of course, on 3D. If you're running a typical sport plane, you can probably get away with about 85%. Jet guys probably run it a little bit lower, but again, it's going to be a feel, so take it up. Once you're finished with your setup, put some flights in. If it's feeling a little bit mushy, you can increase that stick priority a little bit, and that may increase the comfort level of the feel. And all you do to change that is highlight the line, scroll the wheel to where you want it, and it'll give you the percentage or increase that percentage to what you need. And I don't need to go through all of those because that's the same. The bottom two are two of the special mode settings. So if you're flying in trainer, if you're flying in horizon or stability, these are where you can adjust that self-leveling factor. Kind of controls how quick and from where it recovers to self-level in the horizon type modes. Turn assistant is kind of unique. If you're using turn assistant or flying with turn assistant on, that actually is coordinated turns done for you by the system. So it actually will add a little bit of rudder and aileron to smooth the turns out that you're trying to make. Again, this is great in a rough flying scale airplane, something with really scale lines where it hasn't been changed to make it fly better at our Reynolds numbers. You may want to use that turn assistant. It may actually help you out with flying that model. In our application here, we're not going to change that. We're going to leave it at the gain settings, but if you need to change the gain setting, you just highlight the line and you can change the gain and the hold value for that line in this menu. So I'm going to click OK because that's everything in the airplane settings menu. Oh, I jumped out. Never click OK, always click back. I make that mistake every time I work on my stuff. Simple, just go back into configuration. We'll move on to the next setting, which is stabilization, one of the fun sides. Just checking the question, sorry about the pause there. Okay, it says setting the mode. Pitch and roll takes 3 channels that I need for servos. Martin, I don't think I'm really understanding the question. But we can hit me up on the email at sales@Esprit Tech, and I will definitely dig into that with you. When you fly in trim before setup, is it an issue to use an expo setting as well? No, the expo is separate from the gyro system. It's not a built-in, not built into the system, so you can set the expo how you want it. Keep in mind though, at low gain settings and low rate settings, you're going to get a little, very small amounts of movement if the stick priority is low. So you're going to want to balance everything out. Check everything out really well on the ground always before you fly anyway, like we always do. But you definitely don't want to run extremely low rates with the low gain settings and the low stick value, or so low stick priority, because it will be extremely unresponsive. And is it possible to fly these receivers IMAC programs? IMAC does not allow stabilized flight in competition. So if you want to run it in your practice aircraft, I don't know that you would, but if you wanted to, you could put this in a big IMAC plane for practice or for takeoffs, landings, but it cannot be in the aircraft so far as I understand from the rules for this year. You cannot have that in the aircraft while the aircraft's in competition. So it's definitely not going to be something for you guys, especially in your main competition plane. You want to run it in your practice plane, that's completely up to you. But you do not want that in the aircraft at the field on contest day. So hopefully that answers that one. How do you set the gain per surface when in flight? We are going to get to that one. So let's go ahead and go back to camera 2. Perfect. Okay, so let me light it back up here. We're going to go ahead and set our stabilization modes very quickly. I think I'm going to go with the modes that I have. On the screen at the very bottom right of the screen, it'll give you your active mode. That corresponds with your switch position. So for me, I'm going to go ahead and set this to heading hold. And I'm going to set this one to, see if I can scroll back through to M3, change M3 to assist off. Now my 3 is off, 2 is normal, and 1 is heading hold. Failsafe, intelligent, stabilized. There is, Rich, thanks for the confirmation on the IMAC question. I appreciate that. Failsafe, you have the ability to stabilize the aircraft in Failsafe. So when the aircraft goes to Failsafe, if the aircraft goes to Failsafe on a receiver loss, the system would continue to try and stabilize the surfaces. I don't know yet how I feel about that. I think it depends on the speed of the aircraft. I don't think I would want the system to stabilize the aircraft to a point where it kept it in the air, depending on the type of aircraft and where your flying field happens to be situated. So I typically run with the failsafe, the stabilization turned off on the failsafe, but you can run that either way. Just depends on what you feel is safe for your conditions in the aircraft you're flying. And I'm going to go ahead, and once we have set up our 3 mode settings, we're going to go ahead and click back. This is where channel assignment is where you're going to answer the question about adjusting gain values in the air. You have the ability to assign what we call additional channels. Assign primary flight channels is where you would go in and recalibrate the airplane if you made some trim settings. So anytime, let me get into that a little deeper. If you're using any of the special stabilized modes and you add trim in those modes, that trim will be taken as an input, which is very bad. So imagine flipping into hold, the airplane or the system sees a command for right roll. You add left, it's going to add more right. So you always want to make sure anytime you make a trim change to the airplane, before you go into a hold or a stabilized flight mode, you land the airplane, recalibrate under this assigned primary flight channel. So if I click on assigned primary flight, it'll take us back to that calibration screen which you saw in the original wizard. So what we're looking for is assign additional channels. This allows you one, to reassign the flight mode channel if you change it after you've done your initial setup with the wizard. It allows you to add a throttle channel through the system, which we typically don't do. It does allow you to add a failsafe channel. Most of those two would apply more in your multi-rotor setups. And it allows you to assign a switch to shut assist off. If you are using 3 active modes, you could set a third switch, or a second switch rather, to shut the assist off completely. If you wanted to run a trainer, a horizon, and a normal mode, then you could use a second switch to assign assist off. Any of these would be tied to functions that you've created and switches that you've assigned to those functions. Gain tuning channels is where you would assign a control or an input to adjust the gain value in flight. In order to do that, you'll want to create a function. Typically I match it, so if I want a roll tuning function, I create a function in function assignment, name it roll tuning, and assign it to a proportional control. You're going to want to use knobs or sliders for that control because it is a variable value and it runs from 10% to 100% available. Or 100% of your listed gain value. So it will effectively double the gain or drop the gain to 10% of what you already have. You would do that just by clicking on the roll tuning. You would go to edit, you would move the desired control, and it would input that control. Because we didn't create those functions, it won't pick those up. So when we get done, maybe we can go back and create those functions, show you how they would look in the function assignment menu. But that would allow you to add those gain tuning channels, which a lot of people like to use. Let's see, would you use heading hold for hovering a plane? Yeah, that's where it started, was for hovering a plane. It was kind of the trick pony in the early gyro systems. Now, with the algorithms as good as they are, you can actually do your entire flight in hold if you have good command of the airplane. It's really nice in knife edge flight, or your hesitation rolls, or your full field slow roll. It's very nice for controlling like the overroll movement that you would get, because where you stop the stick is where the airplane stops. There's no momentum based overroll. It's really great to use for that kind of stuff. And of course, the hover trick is always fun to do. So you can put the plane up, and put the plane into a hover, get it stabilized, get it solid in the hover, and it becomes almost hands off. You're just managing the throttle. So that's what it was for initially, but now you can use it through a lot of the different maneuvers, and it looks really nice. I think that, let's see, in function assignment, you need to set an extra 1, 2, or 3 for controlling the gyro. Correct, that's the roll tuning commands, the roll, pitch, and yaw tuning commands. One of the things you can do, a lot of people like to do for basic tunings, is you set up a single tuning channel and assign that same channel to all 3 of those commands here in the gyro setup under the gain tuning channels. That way you would have one slider, and it would just give you kind of an overall gain change for all 3 axes. And it does work okay if you just want to make very small changes, or you're getting oscillations in all 3 axes. You can kind of dial everything back with one control. For me, it's the system when you set it and you pick the right model style when you're doing your wizard, the gain is pretty accurate right out of the gate, and you're really making small changes. For those airplanes that respond differently, very differently in different air condition, you may want to add those tuning channels so that you have the ability to adjust the gain. So now that we've set up our additional channels, or shown you where to set up the additional channels, we'll jump back out of that. And we're going to go back again into our Advanced Properties menu. Advanced Properties menu gets a little bit deeper. It goes a little farther into it. Output period, of course, you can set that based on the servos that you're running. So you have the ability to change that. You have the ability to change the output on a number of PPM channels if you're outputting that way. And PPM UDI mode, you can set that to computed or direct in this screen. This one, stabilize EX bus output. That is set up if you're going to run a central box. I'm going to dive a little more into the central box issue on the Rex receivers. Rex receivers, because they are dual purpose, because you have a stabilization system and a receiver system, they continue to always send some kind of signal out of the EX bus stream. So even if you're not making commanded inputs, there's always going to be outputs from the receiver because of the stabilization system. That prevents a central box from making the switch from your primary to your secondary, secondary to tertiary receivers. So that's why we don't recommend using it with that. If you're not looking for redundancy, you just want the fused outputs or the power management you get with a central box, of course you can plug in a Rex receiver. Here is where you would set that up to stabilize that EX bus output. If you're going to stabilize all the channels, output channels on the central box, you would have to click yes to stabilize EX bus, and that would give you that output command. So, or give you that stabilization on all your output channels. You would also set your basic low voltage alarm, controller PID settings. Now this is Gyro black magic. This is where you really need to know what you're doing if you're going to get in and mess with your proportional, integral, and derivative gains. It's basically what's happening now, what's going to happen, what just happened. That's what those three things are. And without a good knowledge base on how to adjust those, it's something you probably don't want to get into at all. You can change a couple of settings in this menu. The stabilize mode 2D settings, it gives you a max roll angle, so you can actually dial that up or down to limit how much the airplane will roll off center under command. So if you set this to only reach 45 degrees, this airplane will not do a roll, will not do a loop. Roll angle limits your roll. Pitch angle keeps you from pulling over the top or pushing under the bottom. This is really great if you want to set up a trainer for the guys at the field. If you have a new guy at the field and you want to get him used to flying, you can limit how much the airplane will roll off center. If it gets off the sticks, it'll come back to center. It makes it very safe and very comfortable for somebody that's new to fly. There are a lot of adjustments in here that are going to be specific to multi-rotor, like the vertical speed, PID transition. Sensor trim allows you to make adjustments to roller pitch angles in relation to the aircraft. So if you are mounted just off of axis, you can actually make a small adjustment to sort of trim the gyro to help it maintain stable flight or flat flight in the airplane. Acro mode settings are kind of fun. This is where you can increase or decrease your roll, pitch, and yaw rates, or how quickly the aircraft will move on those axes. And this is something you're going to kind of use more in the aerobatic settings. You want rifle rolls, of course, you're going to want to crank up the roll rate, and you want to go and hammer walls, you're going to crank up the pitch rate. All of that can be done in the system. Again, though, while you're getting used to flying on the assist, while you're learning to set up the assist, unless you are, you know, you've got a doctorate in gyro, voodoo, black magic, you may want to leave these things at their presets until you really learn the aircraft and get used to how it's going to fly on the system. How does the failsafe stabilize if the receiver is offline? Okay, that's a good question. If you have no power, which is what was in the question, it won't stabilize anything. When we talk about offline, we're talking about offline from the transmitter. So if you are flying and you fly through a direct transmission like microwave, which takes out 2.4, the receiver will still be powered, but it will not be getting a command from the ground. Stabilizing that flight means that while you're not giving any input to that airplane will still try to maintain the heading that it was on. Not so much the heading, but the attitude that it's in. So it will try and stabilize the airplane, keep the airplane from rolling off or bouncing around, anything that was an unintended input. That's what the gyro does. It looks for unintended input. So if I put an input into the airplane, it's going to, let's say a roll input, it's going to roll in that direction. If I don't put an input in, and the airplane sees movement or feels movement through the accelerometers, it's going to put a counter movement in. So let me see if so we're stabilized on this aircraft. Just go back to one, there we go. So this airplane is stabilized. So if I put inputs in, it's going to take those. So if I'm flying level and I'm not putting an input in, and I get a big hit of wind, it's going to try and counter that. That's the noise you hear, is the airplane actually moving the servos to counter what I'm doing. The same thing's going to happen if we're in stabilized failsafe and I lose my transmit. The airplane would still try to maintain that smooth level flight. No inputs would be hitting the receiver, so anything that the airplane did as far as movement from wind or from loss of speed is going to try to be countered by the assist system. And the problem with that, the only problem that I see in that, is if you get in a low speed situation and it tries to counter, it could force the airplane into a deeper stall and cause it loss of control and bring it down quicker. If the plane's moving very quickly, it's going to stabilize that flight. It's going to clean it up on elevator, clean it up on rudder, clean it up on roll, and it's going to continue flying until it runs out of speed. So that's why I say you want to be really in command of where you're flying the airplane at and know what setting is going to be better for you. That was a really good question, though. I appreciate it. In the menu, if we go back to 2, perfect, man, thank you. Dead zone, you can set a gain dead zone for roll and pitch. It does give you a little bit of preset dead zone for each type of model that you're doing, and you typically don't want to change that. The only time I played with it a little bit was in sailplane. We were doing some testing, and giving it a bigger dead zone actually did allow the plane to signal a little better, even with the assist on, than it did otherwise. But that's the only time I would think that you would want to set a big roll pitch dead zone, because you want the system to be active. You want it to be there as designed. All the low pass filter frequency stuff, that's again going to go back to the really in-depth settings that guys are going to want to use with the multi-rotors, because that is a completely different type of stabilization. All of the filtering side is really going to be there. Arming switch, you can actually set it up to where the receiver will only arm with the switch on, which means when you power up, the receiver won't pass any signal. The only time that I really think that becomes critical is in the multi-rotors, where it flies by spinning rotors. So you don't want the system trying to make commands until you're ready, or turning those rotors until you're ready to fly the aircraft. So that's where you typically see an arming switch used. So we'll go ahead and jump out of this menu. Failsafe menu, you guys have seen, it's going to be the same as everything that you've seen in all of the rest of the Jeti receivers. You have the ability to set the failsafe positions based on where the sticks are by clicking Set Failsafe Positions Now, or you can go individually on each out pin and set it to hold, out or off, which cuts power and signal, or failsafe, where you can set a predetermined condition and how quickly the surface goes to that condition. Typically, that's what everybody's used to with failsafe. So let's see, I move my assist between planes. Is 3M gyro tape okay to use? Yeah, absolutely. It's actually what we use here a lot of times. A lot of our stuff transfers from one demo to another, one flying machine to another, one test vehicle to another. And so we just use the tape that comes with it the initial time, and we use 3M tape to back it up. We do sell some adhesive for the gyro tabs, so you check the site, you can get that there. But any of the good 3M VHB tapes work fantastic for mounting the gyros. It's plenty of stabilization or isolation from vibration as well. And then it looks like, okay, that's all of the questions we had there. But failsafe is simple. It's just like what you're used to seeing. Nothing changed in the failsafe system. We don't have anything different in that particular screen. The only thing that did change was that initial setting under airplane settings on whether or not you stabilize the failsafe. So just keep that in mind when you're doing your setup. And then alternative pin configuration, again, what you're used to seeing. These are Rex receivers, so you will see the ability to change outputs E1 and E2, as well as the ability in the servo outputs to change between motor outputs, gimbal outputs, digital in or out, or servo output. So that's something that's a little different in the Assist than what you would see in a standard. You typically don't see motor output settings in your alternative pin configuration except in this receiver. And then receiver outputs is where you would reassign channels at the receiver level. If you needed to do that, you can also set your groupings in this particular screen. So, and again, that's the same as the rest of the Jeti receivers that you're used to seeing. So we won't spend time there. And of course, if you get everything wrong, if everything's going sideways, the bottom thing in the menu is always going to be reset to factory defaults. That will erase everything that you've changed, take it back to stock where you can start over from the wizard and do everything again. So that is the Jeti Assist. Matter of fact, I do want to go back into function assignment real quick. Yeah, actually, I had a question about EX plus UDI, etc. I'll jump to that here in just a second. So if you wanted to use those gain, pitch, or roll tuning channels, it's really simple. Just click Add, name it accordingly. So we'll just name this one Tune. I would go ahead and assign that to a rotary knob in this case. And once you have that done, you're going to want to give it a channel. Because don't forget, anything that you want to function, any of these function assignments that you want to use in the Assist setup have to be assigned to a channel. That's going to be important to you to keep in mind. So if you're flying, let's say a DS-12, you're in the basic configuration with 8 channels. You want to be judicious in how or what you set up, because you only have so many channels to work with. If you're flying 12 or if you're flying 16 channels, if you have the channels available, you can assign as many tuning channels as you want to, of course. So we're going to assign tune to a channel. Then it'd be as simple as jumping back into the Device Explorer. Once it loads up, we're going to go into Configuration, Channel Assignment, Additional Channels, and we're going to go in and we're going to assign roll tuning to that control that we set up. So now, as you see, we're getting tuning on that knob. So what that's going to do is that's going to change the gain value in the aircraft. So you see we're not getting hardly anything, and now we're getting a ton. So it is immediately obvious what it does. Don't forget as well, though, that it is going to, let me see if we can quiet this airplane down a little bit. There we go. Don't forget that that is going to affect how the airplane responds as well, because it's holding back some control for corrections, and the lower the gain is, kind of the more muted the airplane's going to feel if you're running low stick priorities as well. So all of this works together. So there is a little bit of experimenting that's going to come into play while you're flying that. But I just wanted to give you guys a heads up on how to assign those channels. Not too hard to do. I'm going to go ahead and jump back out of this particular menu, and we'll jump into, just go all the way back into our main menu, or our main screen here. Okay, UDI, EXBus, PPM, and PWM. PWM is what your servos take from the receiver. It's the language that the receiver uses to talk to the servos. PPM, UDI, EXBus, SBus, XBus, all of those that you hear, they're kind of the industry names from each manufacturer. Those are all serial communication. So what that means is it takes all of the channels of data and sends that out in a serial stream, or one data stream, across a single connection. So EXBus is our serial communication. We use that to communicate with our devices. We use it to communicate between receivers. A lot of our sensors communicate with the system via EXBus. EXBus is a bidirectional communication serial protocol, so that's why we use it. Started using it in the sensors in our Meson Pro ESCs, because that enables us to not only send commands out to the device, but get data back from that device. Having that serial communication, that EXBus communication, also allows us to program those devices using our Device Explorer, which makes things a lot easier than the way we used to program those devices, or having to have handheld programmers like the Jetibox, or navigate the Jetibox emulator in the transmitter. So EXBus is a serial protocol. That's why you see a single line control, say between a receiver and a central box, is all of the channels of data going to that central box, whether it's 100, 200, or 400, whether it's 8 channels or 24 channels of data, all of that data is going over that single wire. All of the telemetry data is coming back from that central box to the receiver to go back to the radio over that single line. So that's what those three are. UDI is, I believe, it's Universal Digital Interface. It is a kind of a generic serial communication. It's used by quite a few manufacturers. It's something that you're going to see used in some of the simple flight controllers. Some of the Arduino-based flight controllers are speaking UDI. Pretty common. Yeah. So I did have the question again about helicopters for somebody that came in a little bit later. Assist will not function right now, and for the foreseeable future, in a standard helicopter operation. It is going to work in a multi-rotor, where the vehicle is flown based on variable thrust from different motors. But in a conventional helicopter, you have collective mixing, which has to occur, which makes adjustments to the angle of the rotor head, or angle of the blades in relation to where they are as they spin. That's a lot of computation. Jeti does not have a helicopter-specific designer or programmer, so I don't see us moving in that direction with the device. But again, thank you for the question. Okay, XBus, UDI, and EXT. EXT is not a protocol or a language. EXT is just the name on the port of our receivers. So that's one. When you see the EXT, that just is the name of that particular data port, is the EXT port, and that typically will relate because our receivers usually, if we're sending EX bus, it is coming out of the EXT port, or if we're taking telemetry in, it's coming into the EXT port. But a good question. But I think that's all we have for today with the Jeti Assist receivers. If there's anything that you guys didn't get out of this, if you want to see more about this, if you have direct questions, definitely don't hesitate to reach out to us at sales@esprittech.com. You can reach me as well, james@esprittech.com, if you have specific questions, something about the live stream. You guys want to give me some pointers on how to do this? This is my first time doing it. We've never done a live broadcast from our location, so it's been fun, it's been interesting, and we can't wait to see you guys next week.